Paradoxical behavior of math.nan when combined with the in operator. I have the following lines of code. It prints. I am baffled. Any explanation? Python 3.6.0, Windows 10. I have a rock-solid confidence in the quality of the Python interpreter. And I know, whenever it seems the computer makes a mistake, it's actually me being mistaken. So what am I missing? Edit. In reaction to it, cold speed. Indeed, the ids are different. Prints. Maybe there's a good reason why nan isn't a true singleton. But I do not yet get it. This behavior is rather error-prone in my view. Edit 2. In reaction to it, Sven Marnock. Carefully reading the answer of it, Sven Marnock makes it understandable to me. It is indeed a compromise of the kind one encounters when designing things. Still, the ice is thin. Having a in, b, return true if id, a, equals id, b, seems to be at odds with the IEEE 754 standard that nan should be unequal to nan. The conclusion would have to be that while a is in an aggregate, at the same time it isn't, because the thing in the aggregate, namely b, has to be considered unequal to a by IEEE standards. Think I'll use isnn't from now on.
The behavior you see is an artifact of an optimization for the AND operator in Python, and the fact that nan compares unequal to itself, as required by the IEEE 754 standard. The AND operator in Python returns whether any element in the iterator is equal to the element you are looking for. The expression x in it essentially evaluates to any x equals y for y in it, except that an additional optimization is applied by Python. To avoid having to call _eq_ on each element, the interpreter first checks whether x and y are the same objects, in which case it immediately returns true. This optimization is fine for almost all objects. After all, it's one of the basic properties of equality that every object compares equal to itself. However, the IEEE 754 standard for floating point numbers requires that nan not equal nan, so nan breaks this assumption. This results in the odd behavior you see. If one nan happens to be the same object as a nan in the iterator, the above-mentioned optimization results in the AND operator returning true. However, if the nan in the iterator isn't the same object, Python falls back to _eq_, and you get false.
Honestly, how nan is implemented is a total clown town. This is what happens when you override _eq_ without thinking about consequences. Just use isn't and let them handle all that mess.
If you want to see more, please consider subscribing.